Last lecture, we have seen two problems to get the probability distribution of given random experiment. Number one example, tossing of a coin 3 times. Find the probability distribution of number of heads. Number of heads may be asked sometime number of tails. And we got the answer, and I explain how this problem explains the need of studying a probability with the help of variable, because probability based on sample space has certain limitations. I explain the limitation as if I toss a coin 6 times or more than that, number of outcomes tremendously increase, and it becomes difficult to study probability if the tosses are increases, and that is the basic reason why we go for univariate probability distribution. Now today we'll see some different type of examples based on the probability distribution, or you can say based on probability mass function. So let us see example number 3. The probability distribution of capital X is given below. X takes values -1, 0, 1, 2, and 3. Corresponding probabilities are given in terms of unknown constant k. So for -1, probability is k, 0, 3k, and so on. First natural question on the topic is find the value of k. That means for which value of k this table will represent probability distribution. After getting the value of k, we compute probabilities for different events. Number one is chance that my variable takes value greater than -1 and less than equal to 2. Next probability x greater than 0 and probability x less than equal to 1. Fourth bit is compute a probability x greater than equal to 0 given this vertical line is given x less than 2. We'll try to see how such type of questions can be solved. Let us start with bit number 1, find the value of k. Now we want to decide the value of k by keeping in mind this table represent probability distribution. Now you know what is the condition of probability distribution. The given table will be known as probability distribution if the total of probability is 1. So we try to decide unknown constant k such that summation p time xi should be 1. Everybody should make a correction here. It is not summation xi, it should be summation p bracket xi equal to 1. So what is the meaning of left hand side? It is p with -1. -1 is a value of x. Sigma says plus p next value 0 plus p next value 1 plus p2 plus p3. So addition of all these values which is given in your table should be 1. That is nothing but condition for probability distribution. So everybody make a correction here, summation p bracket xi. that is remain to write here. Now what is given? P for minus 1 is k, P for 0 is 3k, and so on. Total should be 1. So answer is 12k equal to 1. Therefore, k should be 1 by 12. So what is the meaning of this value? It is only one constant from real line. For that constant, this table will be taken as probability distribution, otherwise not. It is a single value which gives given Px as a probability distribution. Now, after having the value of k, this table becomes completely known. Put the value of k here 1 by 12, 3 multiply 1 by 12, 5 multiply 1 by 12, 2 multiply 1 by 12, 1 by 12, and total become 1 because we got k under this condition, that is summation pxi equal to 1. So total should be compulsory 1. What is the second bit says? I want probability of the event that my variable x will be greater than minus 1 but less than equal to 2. So this is nothing but addition of that values which satisfies this condition. X should be greater than minus 1, so my first value is 0. Or it may be 1, or it may be 2. So this event satisfied by these three possible values. And to satisfy this condition, I don't require all three at a time. I require any one to satisfy this. So when I want any one, so between the probability, I put plus sign. That is to be remembered. So this event has three possible values, 0, 1, 2. So add the corresponding probabilities, P for 0, P for 1, plus P for 2. In given table, P0 is 3k, P1 is 5k, P2 is 2k. So total become 10k and k is nothing but 1 by 12. So answer is 10 by 12 simplified to 5 by 6. My second calculation is probability x greater than 0. So event says chance that my variable will be greater than 0. So favorable values are 1, 2, 3. X greater than 0 means it starts from 1 onward, but I will not cross 3. Why I will not cross 3? Because my table takes maximum value 3 and minimum value minus 1. So I have to stop at 3. That is why x greater than 0 is probability 1 plus probability 2 plus probability 3. Put the corresponding probabilities from the given table, replace the value of k and simplify. You have second part in the third bit, probability x less than equal to 1. Now I want those values which will satisfy this condition in given table. So x less than equal to 1 have possible values favorable minus 1, 0 and 1 because equal sign is there. Here strictly greater than 0, so I will start from 1. By putting corresponding probabilities, replace the value of k and simplify, you get the answer of corresponding probability. Bit number 4 is nothing but type of conditional probability. This I call PA, given this I call PB. So probability of A given B. From previous chapter, we studied conditional probability. So this is written as probability of A intersection B divided by probability of B. Simple formula what we studied in previous chapter. So the numerator is a probability of intersection of these two events. X greater than equal to 0, favorable values are 0, 1, 2, 3. X less than 2, favorable values are -1, 0, and 1. Now intersection of these two with probability will be numerator and the denominator will be probability x less than 2. So we do two calculations as x greater than 0, favorable collection is 0, 1, 2, 3. X less than 2, favorable collection is -1, 0, 1 from the table. Now intersection quite naturally 0, 1. So the numerator is nothing but P0 plus P1. Total divide probability x less than 2, addition of probability for these three values, P minus 1 plus P0 plus P1. What is given in the question, put it and simplify. So answer will be 8 upon 9. So such type of questions may be asked in exam to calculate probabilities and to get unknown constant in given table. Next example number 4, a discrete random variable x has following PMF, probability mass function. Definition number 3, Px equal k time x semicolon x takes value 1, 2, 3, 4, 5. Function takes value 0 otherwise. What is meaning of otherwise? Otherwise says if x is not taking this number, how much should be Px? Answer is 0. Because Px should be defined for every real values start from minus infinity to plus infinity. That's why this condition is written by default. Now find the value of k, compute the probability x greater than 2 or equal to 2, compute the probability x greater than 1 less than 3. Let us compare example 4 with example 3. What is the difference? The difference is example 5, you have a tabular form which is called probability distribution. And in example number 4, you have a functional form. So you can get a question in terms of probability distribution, or you may get a question in terms of PMF. But the nature of questions which is asked are similar. Here also we want to get the value of k. The method is exactly similar. We find unknown constant in given PMF, probability mass function. What is the PMF? Any function which takes non-negative values and total of that function should be 1. So this is your condition to get value of unknown constant in given PMF, or you may call in given probability distribution. Summation Px should be 1. That's why I said in previous example 3, P should be there. That is forgotten to write. Now my example takes x value from 1 to 5. Function under study is k times x equal to 1. Now how to simplify this summation? Inside summation, only x is changing. K remain constant for each value of x. So I can put directly outside the summation. So I get next step k summation x equal to 1. Next line k curly bracket x equal to 1, sigma says plus x equal to 2 and continue. It is the natural addition of natural number 1 to 5. So you get total 15. Therefore, k equal 1 upon 15. So for this value of k, my given function, which is written as px equal to k times x, will be PMF. Otherwise, this will not be PMF. After having k, we can get the probabilities. Probability x greater than equal to 2. This is called as an event. What is going to be happen? I want chance that my variable x takes value greater or equal to 2. So favorable values are 2, 3, 4 and 5. I stop at 5 because in question x takes value minimum 1 and maximum 5. So I will not cross 5, I will not cross 1. So this is nothing but P2, P3, P4, P5. P2 is 2K, P3 is 3K, P4 is 4K, P5 is 5K because my Px is K times X. That's why I write these probabilities. Make an addition, it is 14 times K and we know K is 1 by 15. So replace here. After having this, we go next bit, probability x greater than equal to 2. What is this? It is another way of getting a calculation by using a complement result. 1 minus complement of this. What is the complement of this? Complement of this is this. X greater, so it is less. Here equal, so complement not equal. If I go from this to this is a complement of x less than 2. Now x less than 2, I have only one number, that is probability x equal to 1. So 1 minus probability 1 is k. So 1 minus 1 by 15 is 14 by 15. Now why I put this as a different approach to solve same question? Because you should understand, if you go by direct calculation, I have to make addition of 4 different algebraic calculations. But if I go with approach of complement, I require only one calculation. So you have to decide, if you want to minimize your calculation, you can go by complement result. Otherwise, you can go by direct. Both are allowed. Third bit is probability my variable x greater than 1, less than 3, not equal, less than 3. So x should be greater than 1 but less than 3. And what is that number? That is only probability x equal to 2. That is 2k, result is 2 by 15. Now I take example 5. Verify whether the following functions are PMF or not. You can recall one example of similar nature in your previous chapter under the heading of probability model. I had given different models and I asked you, check whether following models are probability model or not. The similar type of question is based on PMF. These are different functions and question asks, you have to verify these functions represent PMF or not? Now, to solve this question, you should know what is the meaning of PMF. And that definition number 3 I taught. Any function is known as PMF if that function satisfies two conditions. Value taken by the function should be non-negative and total values taken by that function should be 1. Then I call given function as PMF. Let us verify one by one. Number 1, the given function is a PMF if it satisfies following two conditions. Number 1, Px greater than equal to 0 for all x. And number 2, total of Px should be 1. So consider bit number 1, Px equal to 1 by 4, x taking value 1, 2, 3, 4. Now you can easily see function is a constant. For every x, it takes value 1 by 4, which is greater than 0. So first condition is trivially true. So there is no doubt. Now I verify second condition. Summation of Px with all values taken by x. So this is P1 plus P2 plus P3 plus P4. Function takes a constant value for every x. So answer is 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. And hence total coming 1. Therefore, I give the answer given function is PMF. Now, second bit of the question, Px equal x square by 30. And x takes value 0, 1, 2, 3, 4. Again, you can see the function is a positive because we know from mathematics square value never negative. So for every value of x, x square is a positive. So I can easily claim Px greater than equal to 0 for all x. What about the total? Summation Px equal P0 plus P1 plus P2 plus P3 plus P4. If I replace x equal to 0, 0 divided by anything is 0. X is 1, 1 square is 1 by 30. 2 square is 4 by 30. 3 square is 9, 9 by 30. 4 square is 16, 16 by 30. 30 is a common LCM. Make the addition of numerator. That is also 30. So 30 by 30 coming 1. So again I claim the given function with these values is nothing but a PMF. Now the last explanation is third bit. If Px equal to x minus 2 divided by 5, semicolon, x takes value 1, 2, 3, 4, 5. Now you can see this function is non-negative or not. Suppose I start with x equal to 1, replace here. 1 minus 2 is minus 1 upon 5. So my first condition not satisfied. As P1 is minus 1 by 5, not greater than 0, so I will not check second condition. At this, I will say given function is not PMF because this function does not satisfy first condition. So if first condition is not satisfied, I will not check second condition. Directly, I will put the answer. The given function is not PMF. At this stage, I will stop. In tomorrow's class, I will start a new topic. So I solved totally 5 different type of questions based on probability mass function and probability distribution.